Question 6. This question is about interpreting data. A summary statistics has been presented giving the minimum value, the lower quartile, the median, the mean, the upper quartile, and the maximum value of the data. We are asked to comment on any outliers for the cost of a 1-hour lesson with one of the language tutors in this question. Outliers can be faulty data, but they don't have to be. If you had a large sample, you would expect a small number of outliers, and they would be reasonable data in your calculation. Outliers can affect statistical calculations and should therefore be ignored, especially if you have a small amount of data. For example, if you took the temperature of 10 objects in a kitchen and found 9 of them were between 18 and 23 degrees centigrade, but the last one was an oven with temperature 175 degrees centigrade, the mean of all 10 objects would be between 33 and 38 degrees centigrade, which would not be representative. The median would be between 18 and 23 degrees centigrade, and so would be a better statistic to use. Probably even better would be to ignore the outlier. For the purpose of this question, an outlier is 1.5 times the interquartile range, lower than the lower quartile or higher than the upper quartile. So we need to find the interquartile range. That is the range of values between the upper quartile, 21, and the lower quartile, 16. So the interquartile range is 5. But we want 1.5 times the interquartile range, which is 5 times 1.5, which is 7.5. 7.5 lower than 16 is 8.5. An outlier would be less than 8.5, but our minimum value is 10, so there are no low outliers. An outlier is also 7.5 higher than 21, which is higher than 28.5, so there is an outlier because the maximum price was $40. So there must be at least one outlier, which is the $40, but there could be more outliers in that region. Part B. Describe the skewedness of the data and explain what is meant in this context. Perhaps the best thing to do here would be to look at this on a box plot. The box plot gives the lowest point, lower quartile, median, upper quartile, and highest value. We could put the mean value of 19.8 on this as well, and we know that if the mean is higher than the median, then we have positively skew. It is positively skew as well because as the bulk of things, because this is 25% and this is all 50%, so most things are in this region, less are in this region, and there will be a long tail. So this is positively skewed. Part C. Part 1. What will happen to the mean if the outlier is removed? Well, the outlier is high at 39. If we take that from the data, the total will be decreased, and 39 would be increasing the mean. So if we take the outlier away, the mean would have to be decreased. See part 2. What will happen to the median if the outlier is removed? Let's just consider 5 pieces of data or 4 pieces of data where the median is 12. In those 5 pieces of data, the median is 12. In those 4 pieces of data, and we're going to remove the outlier. We've now removed the outlier, and the median of this set of data is 11, so the median has lowered. The median of this set of data is 12, so the median could possibly stay the same or go lower. Part D. Compare and contrast the distributions of the cost of 1-hour language lessons for Davits' sample and Basil's sample. And again, I think the easiest way to do this, to compare data of this form, would be looking at box plots. So looking at the box plots, Davits' box plot is always to the left. It's lower values all the way through, with median, lower quartile, upper quartile. So generally Davits' payments that he's worked out are generally less. You would also look at the spread of the data. The spread of the data is usually represented by the interquartile range, and so Basil's interquartile range is small. Davits' interquartile range is much larger, so Davits' range of values are wider than Basil's. So Davits' costs are more variable. Also, Davits' distribution is positively skewed because there is less of the data in the lower 50%, so more data here, and then it is spread out more here, so there is a long tail, so that it is positively skewed.
This question is very much about the interpretation of statistics. There's some calculation in the first part about outliers, and the subject of outliers is a really difficult one. There is no exact mathematical way of deciding whether an outlier should be excluded or not. It always is to some extent a matter of judgment, and that generally will mean that some specialised subject knowledge of the area being studied is necessary to make these decisions. On the screen you can see box plots of the Mickelson-Morley experiment, which was done in the late 19th century and was looking at whether the theory of the ether was true or not. The idea of the ether was that there was some invisible medium which was necessary for the transmission of light waves, and the Mickelson-Morley experiment tried to measure the speed of light in 2 directions at right angles to each other. Now, if there were an ether, then the speed would be different at different angles. So, looking at these box plots, we can see that there are 5 identified outliers. So we've got 1 in experiment number 1, and then we have 4 in experiment number 3. And we can see why these have been eliminated. If we, roughly by eye, apply the 1.5 times interquartile range added to the upper quartile or subtracted from the lower quartile, we can just about see that these 2 are above the 1.5 extra, and that these 2 are below, and similarly for this one. what's interesting is that this observation here actually would have been included were it in experiment 4. So some sort of judgment is going on there to decide whether to apply a particular rule or not. An interesting thing that happens with skewed distributions is the order of the mode, the median and the mean. If we look at the positive skew, then in general we'd have the mode, then the median, then the mean. So the mean is towards the skewing tail. For the symmetrical distribution, they will be in the same sort of area. And for negative skew, what happens with the positive is reversed. So the mean is pulled down towards the tail and the median is in the middle. We can look at this happening sort of dynamically. In this situation, the data is generated randomly based on the position of the quartiles and the median, and so it doesn't look like a distribution we might expect. It's not as smooth as distributions we often see, but nevertheless it can show us what happens. So if we drag the lower quartile, median and upper quartile box across to the left, then we can see that we have a positive skew. The mode is this one here, which has gone way off screen because we're so far across, and then we have the median in the middle and the mean towards the tail. If we drag it across to the other end, you'll see in the middle the median and the mean meet up, and then the mean moves across to the left, which again is towards the tail.